We want exercise 6 on this textbook. There is the textbook. Yeah, on page 72, yeah, I think. Exercise 6. So my third takes out a loan of 250,000 to finance a car. She repays the loan over a period of 6 years, starting 1 month after she bought the car. If the interest charged is 9% compound monthly, determine her monthly payments to repay the loan over the required periods. Okay, the required period, not periods. Okay, let's write the given information. Number 1, the loan, 250,000. What else? In 6 years' time, and it compounded monthly, so it's 6 times 12, which is 72. Then I, that is 9%, so we will have 9 over 100. This gives you 0.09, and therefore I equals to 0.09 over 12, because it's compounded monthly. Then X, the monthly payments. Determine, this is what we're determining, the monthly payments. So this is, we don't have that. So since it's a loan, we use this formula. P equals to X 1 plus, that's minus 1 minus 1 plus I to the negative n over I. Then let's make X the subject by dividing both sides by the bracket. So you have on this side is P over the whole bracket, 1 minus 1 plus I to the negative n over I, close the bracket, then equals to X. You can write X on this side, but we prefer to have it this side. X equals to that. So therefore X equals to P 250,000. Hey. 1 minus 1 plus for I 0.09 over 12 to the negative 72 over 0.09 over 12. Then you press your calculator, and after pressing it, 250 over that bracket, and then you should get 4,506.28 cents. So number 1.2, if she sells the car after dress, calculate how much she owes on the loan. So this is the outstanding balance after 3 years. So after 3 years, and remember, okay, let's write the formula first. The outstanding balance is given by this formula, X in bracket 1 minus 1 plus I negative. Instead of having n only, this time we have n minus k. This is where k, it is the number of payments which are already made. Then this is over I. So it says for how long she sells her car after 3 years, which means she paid the car for 3 years, and then she was paid monthly, remember, so it's 3 times the monthly payment, 36. So she paid it for 36 months. I hope you get. Then n is still n, I still I, X, you get that. Balance outstanding, and then X is the monthly payment which you calculated on 1.1. So this is 4,506, 0.28. 1 plus, this is minus 1 plus I 0.09, right, over 12, 0.09 over 12. Then as n, so still 72, remember n was 72 months or 72 times, minus k 36, 2, then over I. Simple, therefore 38 open bracket 1 minus 0.09. This is 0.09. And then you should get 141,711.25. Okay, then number 3. Number 3. Why is number 3? Okay. Mr. Siveko retires on December 2005. He has guaranteed pension paid monthly for a period of 15. Okay, so this pension is he is meant to get it for 15 years. And if he dies before he has received the 15 years pension, his beneficiaries will receive the balance outstanding. If Mr. Siveko dies on December 20, calculate the amount of the beneficiaries will receive. Remember, his beneficiaries will receive balance outstanding. This is what we are calculating, the balance outstanding. So we're still using the same formula we used on 1.2. Balance outstanding equals to x 1 plus 1 minus I to the negative n negative k over I. Then now let us write the values. We get x is the monthly payment. Are we given? Yes. Okay, let me just write it here. X is given as 10 rate 25, right? And then for a period of 15 years, which means n equals to 15 times 12 months, right? Because he was getting it monthly, so 15 years times the 12 months of each, it was 180. And then what is k? Remember k is the payment which you already got. So you got the payments until 31 December 2012. So we have 2 minus 2005. So you got the payments for 7 years. So 7 by 12 months. What is 7 times 12? 84. And then I 8.5%. So remember, is 8.5. 8.5 divided by 100 to get 0.085. Then 0.085 monthly, right? Then let us drag that. We are calculating the outstanding. It'll be fine. Yeah, we'll calculate the outstanding balance. So therefore, balance outstanding equals to, for x 10,325. 1 plus 1 minus a. It's 1 minus 1 plus minus 1 plus I is 0, it's not 85. Let's check. Yeah, it's 8.5%. Remember, 0.085 over 12 to the negative. Total number of the payments which were to be made was 180, and how much the payment went for? 84 months. And then I 0.085 over 12. Everything is in bracket. Get clear first. Yeah. Therefore, balance outstanding equals to. So you press down everything on your calculator. After you get 707,406.04. Then this was number 3, so we're doing the last one, number 4. Stefan takes out a 5-year loan of 900,000 that he can repay by monthly payments of 18,248.75 at an interest rate of 8% per annum compounded monthly. Stefan decides to pay monthly amounts of 20,000 starting in 1 month's time. Calculate his outstanding balance after the 30th payment. Okay, this loan was meant for 5 years if he was paying 18,248, right? But then he decided to pay 20,000. So if we were to use logic now, he can't pay 18,248 for 5 years and also pay 20,000 for 5 years. This one has to be less because he's paying more. Yeah, because he's paying a certain percentage more than this was he's supposed to pay. So let's try to find out how long it will take for him to settle the loan if he's paying 20,000, right? Yeah. So the loan, the SPA cost is 900,000, yeah. And this is what I want us to find, how long it will take for him if he's paying 20,000. But the percent of the loan, the interest rate is still, what is it? On that interest rate, 8%. I don't think it's affected. So 8%, so it's 8 over 100, which is 0.08, and is monthly over 12. Yeah. So let's see how long it will take for him to settle the loan if he's paying 20,000, right? So the formula P equals to X 1 plus, why do I keep on writing plus? It's 1 minus 1 minus I. Yeah, ne? Over I. So there are two ways to do it here. Either you can just take this information and plug it right away, or you can make it the subject of the formula, which is how I prefer to do it. But either way, if you prefer just to plug it here, your own choices. So let me make the n the subject of the formula here. So you get, divide both sides by x, you get P over x equals to, let me make it less confusing, 1 plus I negative I over I, right? Multiply both sides by I, so it will cancel on the right and cancel on the left. So on the left we'll have P times I over x equals to 1 minus 1 plus I to the negative n. Then okay, negative 1 plus I to the negative n. So you see it's negative on the right, it comes to the left, it will be positive. So it's positive 1 plus I to the negative n equals to, we still have 1 on the right, so P times I over x is positive on the left, it comes to the right, negative P times I over x. Then to solve for n, let's use logarithm. You'll revise your laws of logarithm in case you forgot them. 1 minus I is log. Yeah, we have a video where we did the laws of logarithm, so we'll put the link in the description. Okay, 1 minus P times I over x. Then divide both sides, negative n equals to log, it's 1 actually, 1 minus everything, this is on the, which is on the right hand side, 1 minus P times I, 1 minus I, then divide by negative, so n equals to log 1 minus P times I over x log 1 minus I. Therefore n equals to negative, yeah, that's fine, that's n. Then let's plug the information. Yeah, so negative in bracket h equals to negative log 1 minus P is 900,000. Remember, we're trying to see how long it will take to pay this loan. If he pays 20,000 instead of that 18,248,08 over x 21, 2, 3, close the division line, log 1 minus I, we still have I is 0.08 over, just to be sure, is I 0.8, yeah, 8% per annum, so it's still good. Then press your calculator. Okay, there's a mistake here. I 0.08 over 12. Yeah. Over log 1 minus 0.08 over 12. Close. Where's the mistake? Shana, that means this is plus, man. This is plus. Yeah, it counts the left as plus, 1 plus. So remember, this is still plus, this is plus. This is plus. Sorry, yeah. Log 1 minus 900,000 0.08 over 12 20 123 close the bracket log 1 plus 0.08 over 12. So we get 53.679. So it's actually 53 or 54 actually, yeah. So n is 54. But then we're not done with this question. Remember, we have to find the outstanding balance, right? That's the question. It says calculate his outstanding balance. So which means if he's paying 20,000 rand per month, he's going to pay for 54 times, right? Instead of 60 times, because if he was paying 18,000 rand, he was going to pay for 60. Remember, 5 times 12 is 60. Nah. So he's not going to pay for that. He's going to pay for 54 months. So let's see the outstanding balance. That formula, remember, says balance outstanding equals to x in bracket 1. This is where the minus is. 1 plus I to the negative, open brackets, n minus k. It is not n plus k, it's n minus k. Everything is over I. And then monthly payment, that's the 20k, which is paying. And 1 minus. So let's check how after 30th payment, how much is paid. 1 plus, right? 0.08 over 12. And remember, 12 minus n, that's and we just calculated this is 5. I prefer not to round off at this stage. So even when you do it on your calculator, don't round off, just save this thing on your calculator, and then when you press your calculator, press that function answer here, just to make sure you don't leave out any value. Because if you leave out 0.001, it'll still make a difference. Remember, k is the number of payments that you already made. 30. It is given here. Where is k? See, 30. Then you get 30, close, everything, 0.08 over 12, that is I. Then you press your calculator. So 20, 1, 2, 3, close the bracket, open bracket, 1 minus 1 plus 0.08 over 12, close to the negative. So negative, this is where you don't press 54, you press that function answer, because you still save that, it's still there in your calculator, this answer. So you press that function answer, then minus 30, close, over 0.08 over 12, and you get 436,756.04.